Good morning. Welcome to Monday, March 23rd. This is algebra. First, guys, attendance has got to be done every day, but only once per day. A number of you guys are still hitting that submit button numerous times. Today, Naomi, it's you. Now listen, I'd like us to learn how to do solving substitutions with systems, not just graphing. Graphing is kind of a laborious procedure. Nobody likes graphing. Some of you guys are still very much struggling with graphing. So substitutions is a good alternative. I'm going to give you some examples and hopefully make it nice and clear. The first kind of substitutions happens when you've got two equations that are already in slope-intercept form. Take a look, guys. They're already in slope-intercept. Y equals mx plus b. It makes it nice and easy when they're already in slope-intercept. So let's just make them equal each other. Understand that when two lines cross, they equal each other. So the solution is where that occurs. So if this is what y equals, and that is what y equals, then when they equal each other, we will find out where they cross. So I'm going to remove the y's and just set the x portions equal to each other. Now we're going to solve it. Obviously, we have to subtract 4x from both sides. That gives me negative 2x minus 5 equals 7. I'm going to add 5 to both sides. Negative 2x equals 12. And I'm going to divide by negative 2. And that gives me my answer of negative 6. Everyone see how that worked? Now that's not a coordinate. That's the x value of a coordinate. How do we find the y? Just plug it in. I already knew that these were my two starting equations. I know x being negative 6 is where they will cross. I'm going to plug that into one of the two original equations. It does not matter which one. I'm going to choose the first one I saw, y equals 2x minus 5. So I'm going to make the x negative 6 to see what we get. That's negative 12 minus 5, and that's negative 17. So what's the solution to this system? The solution to this system is negative 6, negative 17. That's going to be the answer for this first problem. Whenever your two equations are given to you in slope-intercept form, this is the easiest thing to do. All right? They're not always in slope-intercept form, though. So let's see what happens when they're not. Okay, next example. We got one equation in slope-intercept, y equals negative 3x plus 3, but the other one's in standard, x plus 2y equals 6. Now guys, there's two things you can do, and it's really up to you. Either make sure they're both in slope-intercept form and then set them equal to each other and solve the way we just did. So you would subtract x from both sides and divide by 2. But I'm going to show you an alternative, and you'll decide which one you like better. It's okay with me if you want to go with the first method, no issues. You could decide to isolate the x, get the x by itself, and plug that whole thing into the other equation. Here's how that is done. I'm just going to subtract 2y from both sides, because that gets x by itself. I'm just going to call it 6 minus 2y. Okay? Now that's obviously no solution, but that tells you what x is equal to. As I already told you, when two lines cross, they equal each other. So the option here is take that and plug it into the other equation. So I'm going to plug it in up here. Y equals negative 3 times 6 minus 2y plus 3. See what I did? I just took what x was equal to and I substituted it into the other equation. And then I have to distribute. So we got negative 18 plus 6y plus 3. All we did just now was we just did distribution, as we've always been doing. Now I'm going to subtract 6y from both sides because I'm solving for y. Y minus 6y is negative 5y. While I'm at it, negative 18 plus 3 is negative 15. So far, so good. Final step, divide by negative 5. And y equals 3. Just like in the previous example, we're not finished. We just have one of the coordinates of the solution. So what do you have to do? Substitute it back into the other equation again. See that right there? I'm going to plug it back in. A lot of arrows going on. X equals 6 minus 2 times 3, because that is what I found y to equal. And that's just 6 minus 6, which last I checked was 0. We have a solution. Those two lines are going to cross at the coordinate 0, 3. Okay? Now, that was an alternate way to solve the problem when the starting equations were not in slope-intercept. It's really up to you whether you want to do that or put it in slope-intercept and set it equal to each other. It's all the same to me. There are, of course, two other kinds of systems, as we've already learned. There's one in which the lines are parallel and never cross, and there's one in which the lines are the same and they cross everywhere. So how does that look when you're doing the math with substitutions? Well, I'm glad you asked. Let me show you. So, I'm going to give you a system of equations which are obviously going to be parallel. Y equals 2x plus 1, y equals 2x minus 8. Hopefully you guys can see already the slopes are the same, but the y-intercepts are different, and that defines parallel lines. Parallel lines never cross, so we already know this particular system will have no solution. But let's see what happens. Since they're in slope-intercept, I'm going to set them equal to each other. 2x plus 1 equals 2x minus 8. All right, I'm going to subtract 2x from both sides, which means the variables actually completely drop out. 2x minus 2x is nothing. I'm left with 1 on this side of the equation. 2x minus 2x is nothing. So I'm left with negative 8 on this side of the equation. Well, that's not true. 1 does not equal negative 8. It's not true. And there's no more variable. So there's nothing else I can do. This is the math way of showing you that you can't continue because there's no solution. Okay? This tells you that there's no solution, and that means that they are parallel lines, okay? Now, it was obvious when they were in slope-intercept form that they were going to be parallel. If they weren't already in slope-intercept, you could put them in slope-intercept or use the second method I showed you. Either which way, when you're solving it, the variable will drop out completely and leave you with an untrue solution. That tells you there's no solution. One more thing to do, and that is when they are infinitely solved because they are the same line. And again, I'll make it nice and easy. If I have to leave the first line up there, I'll just change the second one. What am I going to change it to? Well, 2x plus 1. Now, again, I know that you can see they are identical. They're the same line. So we should already know they're going to have infinite solutions. However, let's just show what happens mathematically. So once again, I set them equal to each other. 2x plus 1 equals 2x plus 1. I subtract 2x from both sides to try to get my variables to isolate. But again, they're both going to drop out to nothing, leaving me 1 equals 1. Well, there's no more variable. That's true. But the statement I'm left with is true. What does that tell you? It tells you they're the same line. No more variable, but the numbers we're left with are true. That is infinite solutions. That is the same line. Obviously, there's other ways this could be complicated, whether it's with fractions or decimals, or whether they could be in other forms, not slope-intercept. However you look at the problem, if you could solve it this way, you'll see what the solution should be. With this video, I'm also posting a worksheet. I'd like that to be done by Wednesday. It doesn't have to get done tomorrow. And we'll just work through this process one more time to make sure that we know what we're doing. Okay? Otherwise, I hope all is well. I hope you're enjoying the snow that's falling today and that everyone's still healthy. I'm going to go put on my pajamas.